Hey guys, hope you're all well. So here we have another exam paper. If you want to download the paper, just check the description below. The ages in years of visitors that visited a bed and breakfast on a specific day were recorded as follows. Okay, the age in years of visitors that visited a bed and breakfast. Okay, so there's this bed and breakfast, it's like an Airbnb, and people went there on a specific day. So there was a 15-year-old person, a 17-year-old person, a 30-year-old person, and then we've got some random numbers here, and then we had a 55-year-old person. So you get the idea. The first question says identify the mode. Now, the mode is the number that appears the most. So, what number do we see the most? I definitely see 20. I just want to make sure there's nothing else. Yeah, so we see the number 20 the most, and so we'll say 20 over there. This question says, it is further given that the interquartile range is 14. From that, calculate the value of t. So we know that our interquartile range is always your upper quarter minus, sorry, that's a 3, minus your lower quarter, which is Q1. And we know that to find Q1, we use the following formula, n plus 1 divided by 4. And then to find Q3, we use n plus 1 divided by 4, but then we multiply that with 3. Okay? So if we had to go and look at Q1, n is your number of items. So how many people are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, and then there's 2 rows. So there's 16 people in total. So double check 2, 4, 6, 8, 10, 12. Yeah, 16. So we'll say 16 for n. Okay, and if you had to work that out, you get 17 divided by 4, which is 4.25. Now, that isn't the answer for Q1. That just means that the answer is going to be at that position. So you go to position 4 and position 5. So 1, 2, 3, 4. And you go to position 5. So it's going to be the number that is between those two. So what number is between 20 and 20? It's 20. So there we go. And now if we wanted to go find this one, you're going to end up getting 17 over 4, but then that is multiplied by 3. And so that would give us 12.75. So you'll go to position 12 and position 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's position 12 and here's position 13. And so you would have to find the number that is between those two. So how do you find the number that is between two other numbers? Well, you add them together and you divide by 2. So you will add them together and then you'll divide that answer by 2. Sorry, let me just get a bit more space and I will do that again. So remember, to find the halfway number between any two numbers, you add them together and then you divide that by 2. Okay? And so if we had to work that out, that is going to be 22t plus 2. Okay, so 22t plus 2. And if you divide that by 2, you can divide this one by 2 and you divide that one by 2. You would eventually end up with 11t plus 1. So that is Q3. Now we know that the interquartile range, they've told us, is 14, so we can say 14. And then that's equal to Q3, which is 11t plus 1, minus Q1, which is 20. And now it just becomes an equation to solve. And so we should eventually end up with 11t is equal to 33. And then if you divide both sides by 11, we should end up with t as 3. Now this next one, okay, so we've done 1.2. This one says calculate the mean if t is 3. Okay, and that is what we got over there, so that's pretty cool. Now guys, I'm not going to waste a lot of time on this question because obviously this is really easy. You're just going to go fill in the t value, so this will become 33, 33 over there, and then this will become 11 times 2, which is 33 plus 2. This will become 35. You're then just going to go calculate the average. So you're going to go plug in all of these numbers. I'll actually give you some advice. Notice question 1.4 is asking you for the standard deviation, which is this little funny thing we have on our calculator. So we know that this one's going to be done on the calculator, but you can also get the mean by using the calculator method as well. So don't go say 15 plus 17 plus 20 plus 20, blah, 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 blah. Just go input all of this data onto your calculator, and then we can easily do these two questions in one go. So step 1, put your calculator into stat mode, then press 1 minus VAR, and then go input all of the values. So press 15, then press 17 equals, 20 equals, then do the 20 again and again. If your calculator has a frequency column, then you would have just entered the 20 once, and then under the frequency, you would have put a 3 because there's 3 of them. Now, once you've entered all of the values, press the AC button, then press Shift, press 1, go to VAR. Then you'll see that there's a symbol that goes like this. That over there is the mean, and then there's a symbol that goes like this, and that is your standard deviation. So for the mean, you should get 27.75, and then to get your standard deviation, you've got to press AC again, Shift 1, back to VAR, and then get standard deviation, which is 9.86 if you round that to 2 decimals. Okay, this one says, how many visitors have ages that are less than 1 standard deviation of the mean? So if the mean is 27.75 and the standard deviation is 9.86, then let's quickly minus 9.86, and that'll give us 17.89. So they said how many people have ages that are less than 1 standard deviation of the mean. So they want to know how many people's ages are less than that number over there. So that would be this person and that person. So that would be 2 people. If they said how many people have ages that are more than 1 standard deviation of the mean, then you would add over here, and then you would go find all the number of people whose ages are above that number. And then if they said how many visitors have ages that are between 1 standard deviation of the mean, then what you would do is you would subtract like we have, and you would get that number. Then you would also add 1 standard deviation of the mean, and you would get that number. And then you would find all of the people that are in between those 2 numbers. Okay, but for this one, they just asked for how many people are less, so we just use that. And so there's only 2 people that are less than that number, and so you can just say 2. An athlete's finishing time and the daily temperatures were tracked during 10 years of Comrades Marathon to investigate the relationship between temperature and race completion time. The table below shows the data. So what they're trying to see in this investigation, guys, is, Comrades Marathon, it's a race where people run. Now they want to know, what is the finishing time of the athletes in minutes. Okay, so this question's a bit weird because the Comrades Marathon, the winner normally finishes in like 5.5 hours because it's like 80 something kilometers long, and here they're just using 72 minutes. So whatever, it's just some random, it's not the Comrades Marathon that we see on TV. So it doesn't really matter though. So what they're trying to investigate though is, does the temperature on the day affect the finishing time? Logically, what we might think is that if the temperature is really high, then it might make the runners go a little bit slower, and so the time might increase. And then in the other way around, if the temperatures are nice and cold, then the person's body doesn't overheat as much, and so they can run faster, and so we should expect that the time would come down. That is what we would expect to happen, but we're going to actually go and investigate now and see what the relationship shows us. So the first question hits us off with calculate the correlation coefficient. So that is the R value, which you do on your calculator. So quickly take out your calculator, put it into stat mode, and then choose the A plus BX option, okay? Now you'll see that there's an X column and a Y column. So here's your X values, here's your Y values, and you're just gonna go enter them. So what I like to do is I enter all of the X values first. So I'll say 41, 9, 30, and then once I'm done, I go back up to the top and I start with the Y values and I do all of those. Once all of the values have been entered, press the AC button, then press Shift, then press 1. And now we're going to go to regression, REG. And there you can see that you get different options there, A, B, R. Now I'm going to tell you, go get the A, B, and the R. Because later in this question, at 2.3, they want the equation. And that equation is the A plus BX. So we're going to have to get A and B eventually. So let's just go get all three while we're here. And so to get R, press the button that it shows on your calculator, press equals, and you get 0.96. Then to get A, you need to go back. So press AC again, press Shift, press 1, go back to regression, go to the A, press equals, and to 2 decimals, you should get 10.92. Go back, do the same for B, and for B we should end up with 1.53 if we round to 2 decimals. So the correlation coefficient is 0.96. So let's quickly talk about this correlation coefficient value. Okay, so correlation coefficient, it's an R value. So guys, just as an example, in this experiment, what we were looking at was we had X values of temperature. So if we had to just draw a graph, we had temperature, and then we had finishing time. And what we said was that as the temperature increases, now we're not going to look at the data, what I'm just using as an example, as the temperature increases, you would expect the runners to take a little bit longer, so the finishing time would increase. So we would expect the values to do something like this, where as the temperature increases, the finishing time must also increase, okay? So if the temperature is really hot over here at like 40 degrees, well then the finishing time must be much higher, like 70 over here. Whereas if it's nice and cold, like 10 degrees, well then the finishing time would be a lot faster, like 15, okay? Just as an example. Now, obviously we don't have a straight line. What we have is a whole bunch of points. So we've got random points, okay? Now, if these are what your points look like, then the relationship looks really good, okay? But if your points are a lot more scattered, maybe you rather had a situation where it was like this. Then if you try to draw a line close to all of those, it might look something like that. But notice how far away you are from each of these points. And so how do we actually tell whether there is a good relationship between the two variables or not? Well, that is where the R value comes in. The R value is a mathematical number that tells you if there is a very strong relationship or a very weak relationship. What does that even mean? If we say that there is a strong relationship, it means that there is a very, it means that the temperature has a very big impact on the finishing time because those two variables have a relationship with each other. Whereas if they have a very weak relationship, then it means that the temperature doesn't really have any effect on the finishing time. That is what we mean by if there's a strong or a weak relationship. And the mathematical number that we use to help us tell us whether there's a strong relationship or not is the correlation coefficient. Now, based on what that value is, you can comment on whether the relationship is strong or weak. So if your R value is 1, then we call that perfect. If your R value is -1, that is also perfect. Let me show you. An R value of 1 is the absolute best that you could ever get. That would literally go something like this. It would be a perfect straight line, and the dots would literally be on the line. So there would be a perfect relationship between temperature and the finishing time. So if it's cold, the finishing time would be low. If it's hot, the finishing time would be high. And that would be the same for every single runner who runs the race. That is what R equals 1 would be. So where does -1 come in? -1 comes in if we're looking at different types of experiments where we don't have finishing time. We've instead got something like, let's use an example like this. Let's say they're running this race, and let's say we look at how much time did they sleep. How much time did they sleep the night before? So let's just make a random example. Let's say that if they slept very little, then their body's going to be very fatigued and tired the next day, so they're going to take longer to run the race. And then if they slept for a very long time, well, then their finishing time is going to be much better because their body is well recovered and ready for the race. So then you would see something like this. So notice that because it's going down, that is why we would sometimes get a negative R value. The negative just tells you the gradient, or like the direction of the slope. So if your R value is a positive number, then you're just getting information like that. And then if your R value is a negative number, then it just goes like that. But it's the 1 and the 1, that is the important part that tells us how good the relationship is. So -1 is exactly, it's just as good as a positive 1. The 1, it's just for different kinds of experiments. Okay, and so then if you get 0, that is really bad. That is like no relationship. That would literally look like this. There would just be absolute randomness. It would mean that for some runners, even if it's hot, they will have a very fast or a very low finishing time. And then for other runners, even if it's cold, they will have a very very high finishing time. So there's absolutely no relationship. And so there's nothing that we could say between temperature and finishing time. It would be completely random. Okay, that is what an R value of 0 would mean. It would mean that there's 0 relationship. Now moving on, now different textbooks explain this differently, but as an example, in some textbooks you'll get something like this. If the R value is 0.9, that is still really good. We call that a strong, and this one would be strong positive. This is also perfect positive. And then this is negative, simply because of the gradient, if it's going up or down. And then an R value of -0.9 is also really good, like that's really, really good, but it's just going to be a strong negative. The positive and negative are just based on the experiment that you're doing. In some experiments, when the one thing goes up, the other thing goes down. And in other types of experiments, when the one thing goes up, the other one goes up. Okay, then you could get an R value of like 0.5. It's not bad, so we'll call that moderate. It's almost like average. Okay, so that would be moderate positive. This one would be negative, so it would be moderate negative. Then if you get something like 0.2, then you would call it weak. That's not really good. So that's weak and positive. And then R equals to -0.2, then you would say weak and negative. Now, what about numbers in between that? Like, what about 0.8? Well, other kinds of textbooks, and in some of my other videos, I show it like that, where I would say that, like, anything above 0.8 is considered to be strong, and then anything between, like, 0.4 and 0.6 is moderate. But usually in an exam, they're going to give you very close to the extreme value. So they'll typically... You'll get an R value very close to 0.9, and then you can just say that it's strong positive or strong negative. Or you might get an R value of like 0. I haven't seen it before. And then you would, sorry, I'm just yawning. And then you would say no relationship or something like that. So if we go back to our example now, we got an R value of 0.96, which is really good. And so if we had to comment on that, they're looking for 2 keywords. You would say that it's definitely strong, okay, because it's even higher than 0.9. It's almost perfect. So you can just say strong, and then you would say positive. It's a strong positive correlation. This next question, so we've done 2.1 and 2.2. 2.3 says calculate the equation. So that's just y equals to a plus bx. And we've already found the a value as 10.92 and the b value as 1.53. Now, this question here says, use the equation of the least squares regression line, which is this one over here, to predict the temperature if an athlete takes 57 minutes. So these are really easy. Check this out. If you look at the 57 minutes, that's the finishing time. That is a y value. So you're going to go plug in the y value there of 57. And then you're going to go see what the matching temperature would be. And so here you're just going to go solve for x. So I'm going to take the 10.92 over to the left. And then I'm going to divide the answer by 1.53, and you should get 30.12. Oh, it says round your answer to the nearest whole number. So you should have originally get 30.12, but then if you round that to the nearest whole number, that'll be 30, and then that would be in Celsius. Or let's just say degree Celsius, the way that they wrote it. Okay, so on the answer book, what they gave was, they gave us this over here. Now they want us to draw the equation on top of that. So we have the equation, so y equals to 10.92 plus 1.53x. I just want to double check. So all that you do now is you just got to go draw that line on this graph. So just choose a random x value. So I'm just going to choose a random x value of 10, and I'm going to go plug it in. So choose an x value of 10, and that'll give us the y value of 26.22. So now we go put that on the graph. So 10 is the y, and then 26.22. So this is 22, 24, 26, 28, 30. Okay, so 26 would be, 26.22 would be just above the 26 line. So it would be like there. Okay, and then I need one other point. So now I'll just choose a random one, like x equals to 40 plus 1.53 times 40, and that'll give you 72.12. So we go up at the 40, and then the y value is 72. So just above 72. So it would be, and then up by the 40. So it would be like there. And then you would take a ruler. Now I don't have a ruler, and you would just connect those. Okay, like that. That is it. Now, how far should we draw that line? Well, remember that. So remember, we only used this data to come up with the equation of that line. So we cannot draw this further and further because we don't know if the equation would still be that if we begin to add more points on the outside of that. So you just keep it between the points that you used to find that equation. Point A, B, and D are the vertices of a quadrilateral. Wait, A, B, C, and D. Okay, so B is just hiding over there. It doesn't have coordinates. Okay, are the vertices of a quadrilateral, diagonals, da-da-da-da. I'm just looking for anything that isn't shown on the diagram. Equation of the line BD. Okay, that's quite important. That's probably the only important part. So anything important, I would typically highlight it. So there we go. And that would be for the line BD. So that's the goal when you're reading this, guys, is you're literally just trying to quickly scan and see if there's any information that is not shown on the diagram. First question for 2 marks, calculate the length of AC. So AC, we've got all the coordinates. So the length formula is, it's your distance formula. So x2 minus x1 squared plus y2 minus y1 squared. And so I will just call this my point number 2 and this my point number 1. You can choose whatever you like. It's just to make sure that you don't make any small mistakes. And so it says that I must take the x value of point number 2, which is a 3. So I say 3. Then this one is a minus 3. So I'll put a minus 3. And then this one is a 4. And then this one is a minus 8. Okay, then you can just go plug everything in on the calculator. And they said leave answer in simplest surd form, which should give you 6 square root 5. Okay, next one, calculate the gradient of AC. Okay, so now it's the gradient formula. Guys, you should all get full marks for these questions. There is nothing difficult here. It's just little mistakes that you might make. So I'm going to call that point 2 and call that point 1. You know, I wasn't a student in high school that always used to get like 100%. It only happened once in I think in grade 12, where it was so annoying. I got a 98% for an analytical geometry test, just a normal class test. And the reason I got 98 and not 100 was because in one of these little calculations, I forgot the negative. It was something so small. It was so annoying. But yeah, I never got 100%. But yeah, I remember that. So just look carefully. So we want to find your gradient. So it says that the y value of point number 2, so that's going to be a 4. Then it's the y value of that one, so that's minus 8. Then it's the x value, so that's 3. And then the x value of that one. And that would eventually give us a value of 2. This question says, determine the equation of the line AD. So the line AD, we've got everything we need. So it's a straight line, so y equals to mx plus c. Step 1, get the gradient, so y2 minus y1 over x2 minus x1. I will just call this number 1 and this number 2. And so if you had to go fill this all in, you should get minus 6 minus 8 over 3 minus 3. And that should give us... okay, so now we have the gradient, so y equals to a third x plus c. To find c, plug in a point on that line, so you can plug in this point or this point. I'm going to plug in this one, so minus 6 goes in the place of y, 3 goes in the place of x, and if you solve this, you should eventually end up with negative 7. So the final answer for that one would be y equals to a third x minus 7. Okay, this one says determine the size of the angle CKD. So you go from C, then you go to K, and then you go to D. So they want this angle here. So guys, for a question like this, you know, there are many ways you could get the answer. There are fancy ways where you can use inclination angles and all of that. You definitely can. Just make sure you get to the same final answer. But I think the most easy way, maybe not the fastest way, but definitely the easiest way, is to just do the following. You know, we can easily get the length of this line over here, because it's just a vertical line. So it just goes from y equals 4 to y equals to negative 6. So that would just be 10 units. You could go use the distance formula if you wanted to, but you don't have to because it's just a vertical line, okay? How do I know it's vertical? Because the x values aren't changing. So now I've got the length of this line. I could then go get the length of this line, and I could go get the length of that line. So let's go get the coordinates of k. So to get the coordinates of k, we've got the equation of this line over here. It's BD. And k is the y-intercept. So k's coordinates will be the minus 2. If you didn't know that, you could go get the y-intercept by making x 0, and you will get that it's got those coordinates over there. So then I can go get this length over here. So I can go get the length of kc. So if I know that this is 0 and minus 2, then I can just go fill in my formula. I should write out the formula first. x2 minus x1 squared, y2 minus y1 squared. And then it would eventually give 3 take away 0 plus 4 take away negative 2. And this should give... Now, whenever you're doing these, leave it in surd form, so that's 3 square root 5. So now I've got the length of this line, I've got the length of that line, so let's just summarize that so far. We've got CD, and we've got KC now as 3 square root 5. And then lastly, let's go get the length of this part over here. Okay, so I'm not going to go write everything down, but, you know, you would go write out the formula, you would fill in the values, but you should eventually end up with a length of 5. So KD is going to be a length of 5. So let's just write that here. So now all of a sudden, I've got a triangle that, I've got the length of all three sides. So then what I can do is I can use the cos rule and I can find the missing angle. So remember, the way that this cos rule works is that this is the angle and this is the side opposite the angle. So if this is the angle, then the side opposite that is this side over here. And so we can go for in 10 over there. And then the A and the B are the other two sides. So we can say 3 square root 5. And then 5. And then we repeat those again. And then the angle is going to be the angle CKD, which is this angle that we're trying to find. Now, an area where a lot of learners make mistakes is they go put all of this together. Remember that these two are not a part of this. So this term is by itself. Okay, so these two you can just treat them as two separate things. So you can treat these two together, and then this is a separate part. So if you had to go work this out, this is 100. If you had to put these two numbers on your calculator, you're going to get 70. And then if you had to go type this on your calculator, you end up with 30 square root 5, and then cos of that angle CKD. Now, we want to eventually get this by itself, right? So what I'm going to do is I'm going to take the 70 over. So we're going to end up with 30 equals to negative 30 square root 5 cos of CKD. Then if you had to get cos CKD alone, you would get cos of angle CKD is going to be 30 over, you're going to say 30 divided by that, and that's going to give you negative square root 5 over 5. Now, this becomes like a general solution question. If I gave you as an example cos C equals to negative 2 over 3, then you would go get the reference angle by just putting the shift cos 2 over 3, and then you would go work in the quadrants where cos is negative. So I'm going to go get my reference angle now by just saying shift cos of square root 5 over 5. I'm not going to put the negative on my calculator. And that'll be 63.4349. Now, where is cos negative? Well, we know on the cast diagram, cos is negative in this quadrant and this quadrant. But we're not going to work in this quadrant because that's the 180 plus. And you're never going to find an angle in a triangle that is more than 180 degrees. So we're definitely going to work in the 180 minus. And so if we now had to go and work out the angle, we would say 180 minus 63,4349, and that should give us 116.57 degrees. So that's the answer, 116.57. This question says, if it is further given that the length of AC is 2 times the length of KC. Okay, so AC, which is this one here. Okay, they're telling us that that is 2 times the length of KC. And KC is this one here. Okay. So they're pretty much just saying, well, you can think of it like this. This is the midpoint. K is the midpoint. And that is why this length can be double that length over there. Now it says, determine the area of triangle CKD. So they want the area of this triangle here. Right, now there's 2 ways you could do this. The first way, method 1, you can just use half base times height. And what you could do is you could use this as your base, then you just need to find the height. So if I had to draw that triangle in this direction, it would look like this. So if this was DC, so I'm just taking the shape and I've just rotated it upwards, then K would be over here. You see how K is over there. So to get the height, you would need to know this length over here. So you would need to know this length over here. But that is extremely easy to do, because if you just had to go and draw a horizontal line, and we know that this coordinate here is 0 and minus 2, and we know that the x value anywhere on this line is 3, and we know that because we've made this a horizontal line, because this has to be 90 degrees, then this y value is also going to be minus 2. So this length is just going to go from x equals to 0 to x equals to 3. So that's going to be a length of 3. So that's like finding this part here. So we have the height of the triangle, and then the base is this part here. So you see how your base and your height must always make 90 degrees with each other. Now that base length is very easy to find. It's just going to have 10 units like we already found over there. So then you can just go say, okay, half base, which is 10, times the height, which is 3, and that would eventually give you 15. Now, another way you could have done this question, method 2, is to use the area rule for sin. So you could say area equals to a half AB sin C. Because the way that that formula works is in a triangle, if you have an angle and you have the two sides next to that angle, you can then get the area. So in our previous question, we already worked out this angle as 116.57. We also have this length and have this length if you copied what I did in the previous question. If not, you could go calculate those lengths, and then we can just go get our formula or our answer. So we can say half. Now you're just going to multiply the two sides next to that angle. So this one had a length of 3 square root 5. And then this one had a length of 5, which we calculated in the previous question. And then the angle is 116.57. And so if you had to go plug all this in, you get 14,999, so it all just rounds up to 15. So we got the same answer for method 1 and for method 2. This question 3.6 says, write down the equation of CD. So CD is this line over here. So that's going to be quite an easy one, but let me just remind you, if you have like a hyperbola, and you've often got these, so let's say you had a hyperbola like that, what do we call, these dotted lines, obviously they're called asymptotes, but what kind of equation does this vertical asymptote normally have? Doesn't it normally say x equals to something? So that's exactly what we have here. Can you see that the x value there is 3 and the x value at the bottom is 3 as well? And would you agree with me that the x value anywhere on that line will stay a 3 because we're not moving left or right, we're just going up and down. So the x value will be 3 everywhere on that line, and so that is the equation of that line CD, x equals to 3. Okay, and now this question here. Determine what the numerical value is for the area of triangle CKD, which we've already worked out, over the area of EKCD. So EKCD is there, and there. So it's that shape. Now, can you see that that is actually just two triangles? It's this triangle here, which we've already calculated its area. That is the CKD that we already know, right? And then it's this little area here. So what we actually need to go and do is just try work out the area of this triangle over here, and then we can easily get the area of EKCD. So very easy to do, because we can just use this as the base. So we don't have any angles on this triangle, so we'll just use half base times height. So we can use that as the base. Now, if you have a triangle, just draw any random triangle. If you have your base over here, then the height is always going to be from that base at 90 degrees to the opposite vertex. So it'll be like that. So if you go to the opposite vertex, it will be that one. And if you just go horizontally at 90 degrees, then that is called your height. That is the height of your triangle. Okay, so the base is this one, and then the height is this one over here, Whether the triangle's laying on its side, it doesn't matter. So this is going to be our height, and this is going to be our base. So, and both are going to be extremely easy to find. Because if I want to find this base length, all I need is E's coordinate. But E's coordinate will be very easy to find because I already know the equation of this line, which is that. And so if you had to go find this value, it's the y-intercept of that line, you're going to end up with minus 7. So if I then see that this length, or here it's y value of minus 2, and here we have a y value of minus 7, well then that vertical length would have to be 5. So we now have the base as 5. So we can just say 5 units. Now this part here, getting the height, is very easy because if you go from here and you just go horizontally so that it's 90 degrees, then the coordinates here, it would be very easy to get because the x value would be 0 because you're on the y-axis, and the y value will stay minus 6 because it's a perfectly horizontal line. And so we can then look carefully at this x value, which is 0, this x value is 3, and so this horizontal distance is 3. And so now we can just go use half base times height, and that's going to be a half. Now the base is 5, and the height is 3, and so you'd end up getting 7.5. So we've now gone and worked out that this triangle here has an area of 7.5, and then we know that this triangle is already 15. So if we just add those two together, then it gives us the area of the quadrilateral that they are looking for. So 15 plus 7.5 is 22.5. So then if we want to go work out this, we can just say that the area of CKD is 15 and the area of EKCD is 22.5, and that's going to give us 2 over 3. In the diagram below, x squared plus y squared is the equation of the big circle. Okay, so let's go and let's say that this equation is for the big circle. Okay. Diameter ABC of the bigger circle is drawn and then it's produced to D. Okay, so this is the diameter. All right. GD is the line drawn parallel to the x-axis, passing through Okay, they're probably going to ask us if it's a tangent or something, or they're going to tell us it's a tangent. Okay, don't see anything yet. FCE is a common tangent, so FCE. Okay, so here we have a tangent. Okay, so that's a tangent to both circles. Intersecting the equation of the line GD is y equals to minus 5. Okay, so GD is y equals to minus 5. Okay, got it. And then ABCD is a straight line, and AE is 8 units. AE is 8 units. Okay, so this length here is 8 units. Right. Or let's rather just say that AE is 8. First question, 3 marks. Determine the coordinates of B, which is the center of the circle. So we're going to take that circle's equation now, and we're going to go do that whole completing of the square vibe. So get the x's next to each other, get the y's next to each other, and then take everything else to the other side. Then what you do is you're just going to go and say x squared minus 2x. And you don't have to show this part. If you know how to go from here straight to the final answer, they do accept that. But what we're doing is we're taking this, and then you're going to add. Now you're going to take this number and you're going to divide it by 2. So that's going to be minus 1, and then you're going to square it. Then you're going to do the same here. So you're going to half this number, and then you're going to square it. Now on the other side, you've got a 3. Now mathematically, can you see that we've just added this and we've just added that? So you're gonna to correct that mathematically, we have to add it on the other side as well. So like that. Then what we get is we're gonna end up with 2 brackets. So you're gonna end up with x minus 1. So it just becomes that part, and then it's going to be that part and that part. So y plus 2. Y plus 2. This you can go put on your calculator, and so that's going to be 8, and there we have it. So then the center of your circle is going to have the x value of 1 and a y value of negative 2. So x of 1, y of negative 2, and that is the coordinates for B. This question, determine the coordinates of A, which is the x-intercept of the circle. So you can just go take the circle equation that we have. You can also use the new one that we got in the previous question. It doesn't really matter. Now we know that if ever you want to find an x-intercept, you make y 0. So this will just become like this, like that, and like that. So you're going to end up with x squared minus 2x minus 3. You can factorize that, or you could use the quadratic formula if you wanted to. And so you should end up with x equals to 3 or x equals to negative 1. So it makes sense that it has two x-intercepts. It's got one over there, and then it's got another x-intercept over there. And so these numbers do make sense. So specifically though, the coordinates of A would be negative 1 and 0. Okay, this question says calculate the gradient of AB. So we have the coordinates of B, which is 1, negative 2. We have the coordinates of A, and so you can go do the gradient. y2 minus y1 over x2, take away x1. And so I'll just call this point number 2 and this point number 1. Doesn't matter how you want to do that. And so you should end up with 0, take away negative 2, over minus 1, take away 1. And that would eventually give us a value of negative 1. This question says, calculate the length of CE. Okay, calculate the length of CE. So that's this one here. Okay. So remember that this length here is 8. And so can you see the triangle over there? Now what's really nice is that that is a 90-degree triangle, because here we have a diameter connecting with a tangent, and they always make 90 degrees. And so we can just go use Pythagoras, because we're looking for this length, we have the 8, and we can get the diameter very easily from the information that we have, and then we just use Pythagoras. I've seen them ask this kind of question many, many times. So step 1, let's go get the length of our diameter. Okay. Or let's go get the length of AC, which is the diameter. So we know the radius. If we had to, you could go use the distance formula here, or you could go back to the original, the equation that we had for the circle. Remember, we had x minus 1 plus y plus 2 squared equals to 8. So that 8 is not the radius, it's the radius squared. And then you could square root and get the radius, and then you could multiply that answer by 2. Or, you could just go use the distance formula between A and B, and that would then give you a certain value, and then you'd multiply that by 2. So however you want to do that, you should eventually end up with a diameter value of 4 square root 2. So now we can also then just tell the examiner that we understand that these two lines are perpendicular. And so we could say that AC is perpendicular to CE, because we have a tangent that will always be perpendicular to a radius, right? We've got a radius there and we've got a tangent there. And so therefore we can use Pythagoras. So we can then say that 8 squared, because this is the longest side, is going to be equal to 4 square root 2 squared plus CE squared. And so CE squared would be 8 squared, take away that part there, and that'll be 32. Then if you had to go and take the square root of that, you should get 4 square root 2. So I'm going to say here 4 square root 2. So moving on to this one, determine the coordinates of D. So D is now over here. So we can easily get its y value, because remember what they told us here. They said that this is the line y equals to -5. So it means that any point on that line has a y value of -5. So we know the y value here. So for the coordinates of D, we don't know what its x value is, but we know that its y value is -5. Then all that we need to do now is just get the equation of this line, and then we can just plug in the y value of -5, and it'll tell us what the x value is. So we can just go get the equation between these 2 points, because if you have a line, if you get the equation just between these 2 points over here, that'll be the same for any points on that line. The equation of the line remains constant. Okay, so we can go use these 2 points here to help us get the equation of this entire line. So we know that a straight line is y equals to mx plus c. We've already worked out the gradient actually when we got the gradient of AB, so we know that that's -1. So we can then say y equals to -1x plus c. To find c, you plug in any point on that line. I'm just going to plug in this over here. So you would get that. And then if you had to solve for c, you should get -1. So now we have the equation of this straight line. And so we can then plug in the y value of d. So that'll be -5. And then you can go solve for x. And so you should eventually end up with x equals to 4. So then the coordinates of D will have an x value of 4 and a y value of -5. This question says, determine the equation of the circle with the center D. Oh, okay, so that's this part over here. So we know the coordinates of D is 4 and -5. So if we know a circle's equation is this, then we can easily go say x minus 4 and then y plus 5. Remember, it'll become a plus because it's always the opposite of what we have when we're doing a circle's equation. So for example, if you have a circle that is at -2 and 1, then your circle's equation becomes x plus 2 and y minus 1. Okay, now we got to find the r value. So, you know, normally we would need to plug a point on that circle. That could work. Or we could, you know, if we have this coordinate, we can find the length, and then you've got the radius. But it's usually easier if we have any point on the outside of the circle. You can then just plug it into the x and the y, and then you can solve for r. But it has to be a point on the outside of the circle. You can't use the center of the circle. That's not really on the circle. Okay, so, right. We can easily get C's coordinates because we know that B is the midpoint of AC. So then we can just go find the midpoint of AC by just using the midpoint formula. Okay, but we already know the answer. We already know that the x answer should be 1, and we already know that the y answer should be -2. So what we then do is we can make two equations. So we can say that the x1 plus x2 over 2, we know that that should give us an answer of 1. And we know that the y1 plus y2 should give us an answer of -2 eventually, because we know that that's what the midpoint is. Now we just go fill in whatever we can. So at point C, we don't know it's x or it's y. So then we can just go say, okay, -1 plus the x value of point C over 2 should give us an x value of 1. So we're just saying that the midpoint for the x values, the answer is 1. Then you can just work backwards. So you can take this 2 and multiply it across. So you'd end up with -1 plus x equals to 2. And so if you eventually had to solve for x, you should get x equals to 3. So we've got the x value here. And then we can go do the same process for the y values. So we can take the y value of this point plus the y value of this point divided by 2. And we know that the answer must be -2. And so if you eventually go and solve this, you should eventually end up with -4. So we now have the coordinates of C. It's 3, -4. So we can now go plug that into this circle's equation to find R. And so if we go plug in, that's going to be 3 take away 4, and then -4 add 5, and then you can just solve for R. So you're going to end up with R squared is equal to, that's going to be 1 plus 1, so that's going to be 2. And then if you had to get, well, there we have R squared is equal to 2. And so then we can just fill in the final equation of that circle as x take away 4 squared, y add 5, and then we have to make that equal to R squared, which we already have as 2. And that is the final answer. Given that tan theta is -5/4, with the aid of a diagram and without using a calculator, determine the value of. So these questions, we need to figure out which quadrant we're in. So step 1, they tell us that tan is negative. Can you see they're saying that tan is negative? So we know that this is a cast diagram. So tan is positive in those two quadrants. So tan is negative in this one and this one. So we either going to be there or there. Then they tell us extra information. They tell us that the angle that we are busy with is between 90 and 270. So we should know that this starts at 0, goes to 90, goes to 180, goes to 270, and then back to 360. So 90 up to 270 would be this quadrant and this quadrant. So which quadrant satisfies both pieces of information? Well, it's this one over here. And so that is where we will go and draw our triangle. So like, whoa, like that. Now, they tell us that tan is -5/4. Now, we know that from SOHCAHTOA, tan is opposite over adjacent. So from this angle here, opposite, just put a 5 there, and then adjacent is this one. Now, which of those needs a negative? Well, this is a positive value because it's positive on the y-axis, but this is a negative on the x-axis. So just remember that that is a negative over there. So, because some learners say, oh, but the negative, isn't that for the 5? No, not necessarily. Okay, so let's carry on now. So the first question says, what is the cos of theta? So you're just going to go into this triangle and you're going to go get cos. So we know from SOHCAHTOA that cos is adjacent over hypotenuse. So adjacent over hypotenuse. So we need the hypotenuse. So you're just going to go use Pythagoras. And so 5 squared plus that is going to give us 5 squared plus that. And then you must take the square root of that answer. And so you're going to get square root 41. Okay, this number must always be a positive, no matter which quadrant you're in. The hypotenuse will always be a positive number, no matter where you draw it. Okay. So now we can go get cos of theta, because it's the adjacent, which is -4 over the hypotenuse, which is square root 41. Leave it like that, because they said don't use a calculator. Because if you had to go type this on your calculator, it's going to give you a totally different looking value, because it's not going to let you have a square root in the denominator. Just as an example, if you did have to go type that in on the calculator, it would give you 4 square root 41 over 41, but then you're giving it away to the teacher that you've used your calculator. So this and the calculator version, they both correct mathematically, but the one is when you used your calculator, and calculators will never have a square root in the denominator because they use that process of rationalizing the denominator. Okay, let's go on to this one. So it says, what is 2 sin squared theta? Very easy. Break it up. So if you have 2 sin squared theta, you can think of this as 2 sin theta and then square that. So 2, now sin theta, you just use SOHCAHTOA. So sin is opposite over hypotenuse. So opposite over hypotenuse, that's going to be 5 over the square root of 41, and then it's squared. So now we can say 5 over the root of 41, and then 5 over the root of 41. And so that's just going to become, the 2 only multiplies at the top. So 2 times 5 is 10, times 5 is going to be 50. And then if you multiply square root 41 and square root 41, you can do that on your calculator. They won't know if you just did that part in the calculator. And that would give you 41. So 50 over 41. Okay, now this one over here, whenever we have sin 90 minus theta, or cos 90 minus theta, or 90 plus theta, or cos 90 plus theta, then these are cofunctions. Okay, and it doesn't matter if they have theta or 2 theta or w, whatever. This just becomes the cos of that angle, this becomes the sin of that angle, this becomes the cos of that angle, and this becomes the negative sin of that angle. So if you have cos 90 minus 2 theta, well then it's this one. So it just becomes the sin of whatever your angle was, which in this case they have it as 2 theta. Now we know that that is a double angle on your formula sheet, right? On your formula sheet you've got that formula that breaks this up into that. And so sin 2 theta will end up becoming 2 times the sin of theta. Now sin theta, we know that that is 5 over the root of 41. Cos theta, we already worked it out there as minus 4 over the root of 41. Now you just multiply all the tops together and all the bottoms together. So if you had to multiply the tops together, you would end up with negative 40. If you had to multiply the bottoms together, you're just going to get 41. Here we have an identity. So this left side is where we're going to start. So left hand side. And so, okay, so what have I always told you guys to do? With cos 2x, we know that if we look on our formula sheet, that it can become 3 different things. So you don't want to just go change it into something random over here, because if you choose the wrong one, you could make your life a lot more difficult. So we leave that one alone until we have a very good idea of what we need to do. Okay, so we're just going to leave that as is for now. Then this one, there's not much we can do here. Now, here at the bottom, I know that we want more cos. So there's different ways you can do this. You could take out a common factor of 4 and then you would end up with something from grade 11. But what I always tell learners to do is, if there's more cos at the bottom, or if there's cos at the bottom, then you need to change this into cos. So if you look at your grade 11 formula, sin squared plus cos squared is always equal to 1. Get the sin squared by itself. That'll be 1 minus cos squared. So then you go change this to that, because then we are introducing more cos at the bottom. As I said, there are other ways of thinking about that. You could have taken out a 4 as a common factor, and it would have simplified quite nicely. Now, if we just had to go simplify that, you're going to end up with 4 minus 4 plus 4 cos squared x. So 4 minus 4 plus 4 cos squared x. So these two are going to cancel, and so at the bottom we just have 4 cos squared x. If we now come back up to the top and we look at what our answer is supposed to be, it's just numbers. So we want to try to convert this or these things into just numbers. So for example, we know that if you can take a sin squared and a cos squared, you can turn it into a number. So what I can see is that 3 cos squared x, if I could change this to 3 sin squared x plus 6 sin squared x, then all of a sudden I know that these two can just become 3, because sin squared x plus cos squared x is 1. So if you then had to, you could imagine taking out a 3 as a common factor there, and then you're left with cos squared x plus sin squared x. And then we've still got the 6 sin squared x over here. And then at the bottom, we just have 4 cos squared x. Okay. Now I know that this just becomes 1, so I can just write it as a 1. And then 3 times 1 is just 3. So that is what we now have. Okay, and then there. Right. The next thing is we can start getting a bit of a better idea of what to do over here now. Because if you look carefully, if I change this one to this one over here, then I'll just show you. You get 1 minus 2 sin squared x. Okay? And then plus 3, and then plus 6 sin squared x. And then at the bottom, 4 cos squared x. If I multiply this 3 in now, I get minus 6 sin squared x there. But over here, I have plus 6 sin squared x. So those are going to cancel. And I want them to cancel because we only want to be left with numbers at the very end of this question. Okay. So we can then say 3 minus 6 sin squared x plus 3 plus 6 sin squared x, and that's all over 4 cos squared x. Now those cancel, and so I just end up with 6 at the top and that at the bottom. If you type that on your calculator, it's 3 over 2. So we end up with 3 at the top and then a 2 at the bottom. And there we've done it. So therefore, left-hand side is the same as the right-hand side. Simplify without using a calculator. Okay, 7 marks. Nice.
An unknown phone number sent a long message.
I keep getting this message on my phone, guys. It's so irritating. Okay, I had Siri switched on recently. Yeah, so that's what that was. Okay, so 7 marks. So, right. All I want you to do is just see it as we need to go, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 different things that you need to go and manipulate. Okay, so this first cos x, leave it as it is. There's nothing you can do there. This is a cofunction. We've got 4 of them. So sin 90 minus, okay, I'm not going to have space. Sin 90 minus x, cos 90 minus x, sin 90 plus x, cos 90 plus x. And so we must just remember that this one always becomes cos, this one always becomes sin, this one always becomes cos, and this is the weird one. This becomes negative sin. So this one here, cos 90 minus, is that just becomes sin x. Okay. Sin 48 minus x, we're probably going to have to use compound angles where we're going to have to go and expand it. But let's leave it alone for now because that's going to become quite busy. Let's leave that for now. Maybe we can just forget about it and somehow confuse the examiner and do like some hypnosis or something. And then the same sin squared x, we can't do anything there. And then cos 48 minus x, let's just leave that alone for now. Cos 48 minus x. Okay. Sure, that looks interesting. Okay. Now at the bottom, sin minus x, what happens to that? So many learners will just tell me, oh, okay, if it becomes minus sin x because we take the negative out. It does become minus sin x, but not because of that reason. And if you're doing it that way, it's going to catch you out eventually because if they gave you cos negative x, that doesn't become negative cos x. So let me explain what actually happens. So if you look at sin negative x and you look at a normal cast diagram, we know that this is 180 minus, this is 180 plus, and this is 360 minus x. Now, I've always told you guys that if it doesn't look like any one of these, then you need to change it. And you're allowed to do that by either adding 360 or subtracting 360. Why are we allowed to do that? Well, let's say you were randomly over here and then you added 360. You would be back at the exact same place. And if you subtracted 360, same thing. So take this minus x, add 360 to it, And then because you're plussing here, the order doesn't matter. So you can rewrite this as 360 minus x, and that's there. And we know that sin is negative in that quadrant, so it just becomes negative sin x. Now, in an exam, you do not need to go and show all of this. You literally go straight from there to there. Okay. And then cos 24 and cos 66, I'm going to leave for now. But I know that there's something going on there because they add up to 90. But I also know that 24 is half of 48. And so my brain is starting to just visualize that. Wow, so this is quite hectic. Check this out, guys. I think what they're doing here, just switch the places of these two quickly. So let's just write it as cos x. No, that's not switching the place, Kevin, if you're writing it exactly the way it was. Cos x, sin 48 minus x. Okay. Then break this up into two sin x's. So sin x and another sin x, and then a cos 48 minus x. Okay. Then leave the bottom exactly as it is. So what I'm kind of seeing is that this angle is repeating over here. Okay. And then so I'm thinking that maybe, check this out. I know that in both of these terms, what is the common factor? There's a common factor of sin x. So I'm going to pull these sin x's out as a common factor. So take out a sin x as a common factor. And then you're left with cos x sin 48, minus x, plus sin x times cos of 48 minus x. Okay, and then at the bottom, let's close that bracket. And then at the bottom, we've got, I just had the weirdest craving, something I haven't had in so long, but I used to have it as a kid when I was much younger, is, let's say my mom was at work and my dad was at home with me, and I wasn't old enough to make food, but he would take two slices of white bread, put a shit ton of cheese on that. I remember like barely being able to chew it, and then placing that in the microwave, and then it would come out like super hot, and the cheese was all melted, and then he would put tomato sauce on it. Wow. I remember that tasted absolutely amazing. I think I should make myself that one of these days, just for the fun of it. And then at the bottom, we've got that. Now, this sin x and that sin x can cancel, so we're just going to get rid of those. And then we've still got this little negative chilling here. It's fine. Okay. Now, this here is going to actually become a compound situation. Because I can see we've got a cos, sin, sin, cos. So it's not exactly, but we can move things around if you want, just to make it look a little bit more like what we normally have. So I know that we normally have the sin first, and then we have a cos. So because these two expressions are being multiplied, you can just rewrite it as sin 48 minus x times cos x. You can just switch them around. And then here you can just switch these around as well. So cos 48 minus x times sin x. So now we have exactly this over here. We've got the sin of an angle times the cos of an angle plus the cos of an angle times the sin of an angle. So can you see that we have this exactly, where our alpha is the 48 minus x, and our beta is this x. So if we then take it from this, and we rewrite it like that, then we're going to end up getting sin of 48 minus x plus x. Okay, that's what the top's going to become. And then the bottom is just going to be negative cos 24 cos 66. Now, the x's cancel here, so we just end up with sin 48. And then at the bottom, we've just got negative cos 24 and cos 66. Okay, so I now notice that this is double that. So what I'm going to do then is I'm going to convert that sin 48 into its double, I'm going to use the double angle. So we know that if you have like sin 2x, then it becomes 2 sin x cos x. So if we have sin 48, then it becomes 2 sin 24 cos 24. So 2 sin 24 cos 24. And then at the bottom, negative cos 24 times cos 66. Okay. These cos 24s can cancel. And so you're just left with 2 sin 24 over cos 66. And there's still a negative over there. Now, can you see that these two angles add up to 90 degrees? So this is where we use the whole co-functions thing. So we can just change one of them. So you need to know, you can even go type this on your calculator. You need to know that sin 24 is the exact same as cos 66. Sin of 10 is the same as cos 80. Cos of 11 is the same as sin 79. As long as they add up to 90, they are all exactly the... you can go type it in your calculator. You can go check what is cos 15 on your calculator, and it'll be exactly the same as the sin of 75, as long as they add up to 90. This is the whole co-functions thing. So you can decide if you want to change this one or if you want to change that one. It doesn't matter. Just don't change both. What is both? Don't change both, because that would be a bit weird or silly. So if I change the top one to cos 66, then the cos 66 is cancel, and then I'm just left with a 2 and a negative, so the answer will just be negative 2. Given this expression, then they say simplify it to a single trigonometric ratio. Okay, so what we have at the moment is we have cos 60 minus x plus cos 60 plus x, and then that's all squared. So I think what we can go do, guys, is we can go take this one, and then we can go take this one, and we can go expand them using our compound angle formulas. So let's just look at this first one. It's a cos something minus something, so that's this one over here. So what we'll do is we will take this and we will go and rewrite it like that. So it will become cos 60 cos x. Then it says it becomes a plus. So even though that's a minus, when you expand it, it becomes a plus. So plus sin 60 sin x. And then I'm going to go do the exact same with this other one. So that's going to be a cos something plus something. So that's this one. So then I'm going to expand it using this now. So that becomes cos 60 cos x minus sin 60 sin x. And then all of that is squared. Now what's nice though is if you look carefully, we've got a sin 60 sin x minus a sin 60 sin x. So that part cancels. And so what we are now left with is cos 60 cos x, and then another one, but DJ colored, plus cos x, and then squared, because these two cancelled. Now we need to remember that cos 60, or anything with a 60, 30, 45, that is a special angle. And so cos 60, if you just type it on your calculator, it's a half cos x, and then this one will also be a half cos x, and then that's squared. Now a half cos x plus another half cos x just becomes 1 cos x. I'm just going to say cos x, and then that needs to be squared, and so it's going to be cos squared x as our answer. Next one, hence, determine the general solution. So now we've got this expression to the power of 2, so we know that that is just cos squared x. So we can just replace it with cos squared x, and we make that equal to 3 over 4. Then we're just going to go get x alone by square rooting, so we're going to say plus minus, type that on the calculator, and it should pop out plus or minus the square root of 3 over 2. Okay, so now we just have an easy general solution type of question. So for the first part, we've got cos x equals to square root 3 over 2. And then down here, we will do cos x equals to the negative square root 3 over 2. So let's go get our, the way that you do this now is just go get your you go get your reference angle. Sorry guys, I've been recording for quite a while today. So the reference angle you get by just saying shift cos square root 3 over 2, and that gives us 30 degrees. Of course, I should have remembered that. And then we know that cos is positive in quadrants number 1 and quadrant number 4. And so you would say x equals to 30 plus k times 360. K is an element of z. And then in quadrant number 4, you would say 360 minus 30. So it's just going to become 330 plus k 360. K is an element of z. Now for this second scenario where we've got the negative, we're still going to go get the reference angle. And when you get the reference angle, you don't put the negative on the calculator. And so you're still going to get a reference angle of 30. But then you're going to work in the quadrants where cos is negative, which is going to be quadrants 2 and quadrant 3. And so you're going to end up with x equals to 180 minus 30 plus k 360 k element z. And so if you had to simplify that, you get 150 plus k 360 k element z. And then for quadrant 3, you would say 180 plus 30 plus k 360 k element z. And then if you had to simplify that, you'd get 210 plus k times 360. K is an element of z. Now, you might be from a school where your teacher uses this other kind of method for cos, where your answer is just going to have plus minus. That is also valid. Your answer will look a little bit different though. So your answer would be, let's do this in a different color. So an alternative way that the answer would look would be x equals to plus minus 30 plus k 360 k element z. And then the other way is plus or minus 150 plus k 360 k element z. There are some schools in South Africa that do it that way. Totally valid, perfectly okay. Sketched below is the graph of f equals to cos x minus a half. So guys, that is just a normal cos graph that has been moved down by half a unit. Okay, so just a normal cos graph. Normally it would go like this, and it would have a maximum value of 1 or a higher value of 1 and a lowest value of minus 1. But now they've just moved it down by a half. So this is going to go all the way down to negative 1.5. So we can see that over there. And then this point over here would move down to a half. And we can see that over there. Okay. Okay, so this question says, determine what the range is of this expression after you've plus 1 to it. So forget about the plus 1 for now. What is the range at the moment? Well, the highest value is a half and the lowest value is negative 1.5. Then if you add 1 to each of those, so if you had to, so it's currently from negative 1.5, which is negative 3 over 2, and the maximum is currently a half. Now if you just add 1 to each of those, and you add 1 to this one, then you're going to end up getting negative a half and 3 over 2. So that is your answer. Y is an element going from negative a half to 3 over 2. If you want to write it in set builder, you can say y is bigger than or equal to negative a half and smaller than or equal to 3 over 2. The memo got that part completely incorrect. On the same set of axes, sketch the graph of g of x equals to sin x plus 30 over the same interval on the grid provided in the special answer book clearly indicates. Okay, so guys, on your calculator, put your calculator into table mode. So just press mode, table. Now go plug in the equation. So just go type in sin x plus 30. So sin, then to get x, you typically have to press the alpha button and then look for the x on your calculator, plus 30. Now for g of x, just skip that one. Now for the starting position, they want us to start at minus 120. Okay, and then for the ending position, do 240. Now for the step, I've kind of changed this recently. So normally for the step, I would have just left this one as a normal 90. But when they've moved the graph up by 30 or 60, let that be the step. It just gives nicer values on the calculator. So choose 30 as your step, and you should get all of your different values there. Okay, so if you've done this correctly, you should get an x values of negative 120, negative 90, negative 60. Yeah, so there's quite a lot of x values here, but negative 30, and then it goes all the way to 240. Now your y values, just to make sure we're on the same page, this should be negative 1, negative 0.87 if you round up, negative 0.5, 0, 0.5, and then it goes on and on and on and on. Okay, so we're going to go plot all of those points now. So minus 120 and minus 1 is going to be there, minus 90, and we can kind of skip that one if you want, and we can just go straight to the minus 60 and negative 0.5, which is there. And then we'll just connect the dots and it will go through that anyways. Then negative 30 and 0 is there, and then 0.5 is over there, and then we'll carry on. Okay, and so that's what I got. I didn't, anything that was like a negative 0.87 or whatever, I just left that out because I know that if I connect the dots, I will get to, I'll go through those points anyways. Something like that and something like that. Okay, I think I can do that a little bit better. Just remember, guys, in your exam to take your drawing pack X37 that they give you before each of your exams. It's like a little tablet with a highlighter that you can draw, and then if you make a mistake, you can erase it again. They used to do the tablet X36, but they've recently come out with tablet X37. But what's weird is your school won't give it to you unless you ask about it. It's like this weird thing. Now, obviously, guys, I'm talking absolute shit. So let's carry on. I don't know why I come up with such terrible jokes. Okay, so there we have it. Done this one, and then clearly indicate intercepts. Okay, so let's indicate the intercepts. Boom. And this one was 0.5, and then negative 30 and 0. Okay. This one, write down the values of x where g has a minimum value. Okay, so that's this one. So write down the values of x where it has a minimum value. So you can see it's got a minimum over there. Minimum just means the lowest point. So it's there and there. So you can just say x is minus 120 or x equals to 240. Don't do something like this, because then you're kind of saying that it goes from minus 120 to 240. But you're not saying from minus 120 up to 240. You're just saying at minus 120 or at 240. This question, for which values of x is that smaller than 0? So just look carefully. They're saying that. So remember that when you've got this over here, this is your first derivative. And that is another name for gradient. So they're actually saying, where is the gradient of the graph smaller than 0? So where is the gradient? Negative. Where is gradient negative? Now remember that positive gradients go this way, negative gradients go that way. So they're pretty much saying, where is the graph of f, which is the original one, where is it going downwards? So that would be all of up to there. So where is that? Well, you can just, in your test, just say there. Okay, and then just draw like an arrow like that. If only life was that simple. Of course, we can't do that. So, your key is full of jokes tonight, man. Okay, so you're going to say from there up to there. So you need to use the x values. So the x value here is 0, and the x value here is 180. So you're going to go from 0 to 180. And then you could say x is an element. And then we don't include the 0 and the 180. If you prefer set builder, you could say x is bigger than 0 and smaller than 180. 6.5 says amplitude. Now amplitude is if you have a graph, let's say we've got a x-axis here, but let's say your graph is all the way up here, okay? And let's say that this is a value of 4, and this is the value of 5, and then the lowest value would be at a value of 3. Okay, so your amplitude is the distance from its middle, so from the middle to the maximum or to the minimum, however you want to look at it. What is that length? So in this example, that length would be a 1, because you're going from 4 up to 5, or you can think of it as going from 4 to 3. It's 1. So if you look at our graph of f, let's get rid of this other one, this green for now. If we look at f, we can see that, okay, no, that's not going to help. Let me get a, okay, I don't think we need that red one for the next part of the question. Okay, so if you had to look at the middle, it would be, so if this is a half and this is minus 1.5, then the middle would be at negative a half. So this is the middle position. So what is that length from its middle to the top? Well, you're going from minus a half to positive a half. So it's just a length of 1. So the amplitude is just 1. The amplitude is also the number that is in the front over there. If there was a negative there, though, you won't take the negative. Amplitudes are always positive numbers. Okay, so it's the next day now. That's why I'm wearing different clothes. I totally forgot to do question 6.6. So here I am doing it again. Well, to be honest, I actually did it, but I forgot to press record. So I was looking at it this morning and I'm like, oh, man. Okay, so describe the transformation to go from f, which is currently this, to negative cos x. So they pretty much just want to know, how do you transform a graph that looks like this into a graph that is negative cos x? So the first thing we need to do, so if we just write out f of x equals to cos x minus a half, and we want to get it to become that. And they want to know, how do you do that? Like, how do you transform it? Well, the first thing we need to do is get rid of this minus a half. So the way that you do that is you just move the graph up by half units, because then these two would cancel out and then you don't have anything over here. So that's going to be the first thing we're going to do. We're going to translate up half a unit. Okay, so then what we would have is we would then have y equals to cos x, because we've gotten rid of the this negative half. So that's what we have at the moment. So now how do we go from here to here? Well, all that's changed is that there's now a little negative there. So you can just write here, put a negative in front. Ha! If only life was that easy. Of course we can't say that. Come on, don't be silly now. So how do we mathematically go from this to this? Well, that is actually a reflection in the x-axis. Let me explain. If you have an x and a y system, and let's say we've got a random little point here and the coordinates are 3 and 2. If you reflect something in the x-axis, the x value doesn't change, but the y value flips over. And if you were, for example, let's say you were here, and then you reflect it that way, once again, the x doesn't change, but the y flips over. So if you then had to take this, so that's what happens when you flip over an x-axis. So if you had to take this expression and flip over the x-axis, we know that the y's become the opposite of what they were. And then if I have to take this now and get the y alone again, I would end up dividing by -1, and so I'd end up with negative cos x on the right. And that's what we have here. So the next thing we would do after the translation is we would do reflect over x axis. And so for 2 marks, you would need to go and list both of those bad boys over there. Can I get a oh yeah? In the diagram below, sorry guys, I get these random moments in life and it's good to express myself, okay? In the diagram below, PS is a vertical tower standing on a horizontal plane. Right, so some learners do struggle with the whole 3-dimension thing. So I don't know if that helps, but pretty much this part here is on the floor. Okay, you see how I've added like a little floor in the background here. So you could think of this as this part here is completely flat on the floor. You can think of that as maybe like a netball court. And then this part here is like the netball goal, or the pole, you know, where you have to score your points when you're playing netball. So this is like that vertical pole over here. And then you could think of this as like a piece of rope from the ground up to the top of the netball pole, and then here's another piece of rope going up to the top of the netball pole. Okay, so I hope that helps with the visualization of what this actually is in 3 dimensions. And so in the diagram, okay, I think everything they've told us, they've shown us on the diagram. So it says, first question for 1 mark, write down the size of angle SRQ. So you start at S, then you go to R, and then you go to Q. Okay, so they're looking for this little angle here, which is on the ground. So if you look in that triangle, you can see we've got this angle and we've got this angle. So we know that all angles must add up to 180. So we can just say that SRQ is then going to be 180 minus beta minus alpha. And that's just because of sum of angles in a triangle. And so there's the answer for that one. So it's 180 minus beta minus alpha. This one for 3 marks says, show that PS is equal to that. So I don't look at this when I'm solving these questions. What I see is go and find PS. And then once I have an idea of how to find PS and I've got the basics, then I will slowly but surely make sure that it looks like that. So let's just go find PS. Don't look at any of that for now. So first of all, where is PS? Well, PS is over here. Okay. So we know that PS is inside a 90-degree triangle. Can you see it over there? Okay. So we can definitely use like your normal sin, cos, tan, but the problem is we don't have any sides in that triangle. So then the next thing I would ask you is, which triangle has the most information? Well, that would be this one over here. So then which side do you think we should try and find right now so that it will help us in the PQS triangle, which is this one over here? Which side would help us? Well, obviously that's going to be this side over here, because if we can find that side over here inside this triangle, then we can use that side inside this triangle. So that's the next goal of this question. Let's go find this one by using this triangle here. Now this triangle is not a 90-degree triangle, so we're going to either use the sin rule or the cos rule. I think the sin rule would be pretty straightforward because we've got this angle and we've got its opposite side, and then we've got this angle and this is the side that we are looking for. So the formula is A over sin A equals to B over sin B. Learners often ask me, they're like, Kevin, my teacher writes it the other way. My teacher says sin A over A and sin B over B. Guys, you're allowed to use it any way you like. You're going to get to the same answer at the end of the day. Okay, so I'm going to take this one over this one. So y over the sin of its angle, which is beta, equals to QS, which is what we are trying to find, over the sin of its angle, which is 180 minus beta minus alpha. Now we just need to talk a little bit more about this part over here. So we know that on a cast diagram, if we had like 180 minus x, and I said to you, what is the sin of 180 minus x? Well, you would know that sin is positive in that quadrant, and you would just reduce this to sin x. So whenever you have the sin of 180 minus something, it just becomes the sin of that thing. So we need to manipulate this a little bit because at the moment we don't have it looking exactly the way we want. So the way that you do that is you go like this. You take out a negative as a common factor out of those two. And so what you would then be left with is beta plus alpha. Let me explain. If I had to put this negative back inside, it would give me negative beta, which is what we had. And if I had to put this negative back inside, it would give us negative alpha, which is what we had. So we haven't changed anything. We've just written it in a better way because we know that whenever you have the sin of 180 minus something, now the something is this over here, then it just becomes the sin of that something. And so we can now say, we will now have y over sin b equals to qs over the sin of beta plus alpha. Okay, and obviously that's where that's going to come from later. So now the next thing is, okay, so now we need to get the qs alone in this equation. So normally I would tell learners whenever you have a fraction equal to a fraction, we do cross multiplication. So what that means is that this part goes over there and that part goes over there. But don't do that part because we're trying to get qs alone. So just take the sin, this part, take that to the left. And so we should eventually end up with qs is equal to y multiplied by the sin of beta plus alpha. And that is all over the sin of beta. Okay, so now we have qs. Fantastic. So now we go work in this triangle. And remember that this is a 90-degree triangle, so we can just use the normal grade 10 trigonometry, SOHCAHTOA. So let's just write out SOHCAHTOA. So SOHCAHTOA. Maybe you use something else. Some old hens cackle and howl till old age. I've heard some very naughty ones as well. But the point is that we have this angle. Okay, so let's just use that angle. Now we are looking for PS. So PS is here. So that's the opposite. And we already have this length, which is the QS that we've just found. So that is the adjacent. So opposite and adjacent is tan. Oh, what do you know? What do you know? So now what we go do is we go say, but notice we're not looking at this. It just gets there by itself. So now we're going to go say that the tan of the angle we're using is equal to the opposite, which is PS, over the adjacent, which is QS. Okay, now I'm going to get PS by itself. So PS, if I take this over to that side, I'm just going to write it on this way around. So you'd get PS is equal to QS multiplied by the tan of theta. Now we can go plug in the QS. So we end up with PS equals to y sin beta plus alpha times tan theta. And that is all over sin of beta. And it's exactly what they wanted over here. It doesn't matter whether we have the y first or the tan theta at the end. It's all multiplied. So it's all the same. And that's over there. So notice we didn't try to make that. We just went and solved, and it gets there by itself. This one says, I get really annoyed with these types of questions. They're so silly because check this out. They give us the y. They say find the length of PS if y is that. So we've got the y value. They give us the theta value. They give us the beta value and the alpha value. So we're literally just going to go plug in now. What a waste of time. So PS is going to be the y value, which is 116, times the tan of theta, which is 57, times by the sin of beta, which is 102. This is literally like, can you use your calculator? Beta plus 27 over sin of 102. Okay, go ahead, type it all in. And we should get 141.92, and then I'll put that as meters. Last one, determine the angle of elevation from R to P. So from R, so let's go to R, and then we're going to P. So we're going to P, so they want this angle over here. So let's see, and that's for 4 marks. Right, so the only side or the only information we have in that triangle, first of all, it is a 90-degree triangle, so we can use our SOHCAHTOA. So we've got this length, and we don't have this length. I wouldn't even try to find that length because there's no information that helps us with that. I would then try to find this length over here because we've got quite a lot of information inside this triangle. And I'm not sure if we're going to have to use these values, but let's just see how it goes. Yeah, we definitely will have to. So we can use this triangle now, and we'll help us, or we'll use it to help us find this length over here. Because once we have that length, then we can work in this triangle again to find that angle. All right. So let's just highlight this triangle for the 64th time. Right. So pretty much quite an easy question because we've now got the y value as 116. So we can just use, and now we're trying to find this length. So I'll just use the sin rule again. So A over sin A. We can't use SOHCAHTOA because it's not a 90-degree triangle. And so I'll just use the 116 over the sin of its angle again. So 116 over the sin of its angle, which is beta, which is 102. And then we're looking for this length here, which is RS. And then we'll say over the sin of its angle, which is the one opposite, which is alpha, which is 27. Okay, now to get RS alone, you can just take this up to the top left, and so you end up with 116 sin 27 over sin 102, and that's equal to RS. So RS should give us, now don't round off because this is not a final answer, so that's going to give us 53.8394 meters. Okay, so now we have RS, so let's scratch out all of that. And so now we've got this as 53.8394. Okay, now if we're looking for this angle here, then we already have the opposite and we have its adjacent. So if we go back to SOHCAHTOA, which one uses opposite and adjacent? Tan. So we will say the tan of the angle that we're looking for, which is just going to be, let's call that PRS, is going to be opposite over the adjacent. And then to get the angle alone, you're going to do the whole shift tan thing on your calculator. So shift tan of whatever we've got there over 53.8394. And if we do that, we get 69.23 degrees. In this question, we have a proof, and specifically they want us to prove the opposite angles of a cyclic quad add up to 180, and they specifically want us to show that these two add up to 180. So when they want those two to be 180, then you are going to make a construction. You are going to construct from the center, and you're going to construct the radius OS, and you're going to construct the radius OQ. So we can just say construct radii OS and OQ. Okay, and then you can just have O1 and O2 now. Now, what do we know about if we have, if we have a circle and if we have an angle at the center? What do we know about this angle compared to this angle? Well, we know that the angle at the center is double the angle at the circumference because of angle at center equals 2 times angle at circumference. That's the reason. So we can say that O2 is going to be double the angle P. So we can say that O2 is going to be 2 times angle P, and that is because of angle at center equals 2 times angle at circumference. Okay, so we're now going to do the exact same thing for this angle. So this angle will be double that one. It's always the one on the other side. So this one will always be double that one, and then this one will always be double that one. Okay, and so O1 is going to be 2 times angle R, and that is for the exact same reason, angle at center. Now the next thing, if you take O1 and you add it with O2, we know that these angles together, if you add them together, they should add up to 360. Why? Because they are angles around a point, right? It's just like having, angles around a point adds up to 360 degrees. But we also know that if we had to go replace O1 with 2R, because that's what it also is, and we had to go and replace O2 with 2P, then we could make that equal to 360. We could then go divide everything by 2, and you would end up with 180. And so we've just proven that R plus P equals 180. PR is a tangent to the circle. QWZ is a straight line. QSVW are points, and then they give us some angles. But everything that they've told us here is already on the diagram. So that's all that I'm looking for. First question, determine the size of angle V. So angle V is over here. So immediately what I saw was that we've got a cyclic quad. And we know that the opposite angles of a cyclic quad, so this one and this one, should always add up to 180. So we could say that angle V plus angle Q2, whoops, I just dropped my car keys, should add up to 180. And that is because they are the opposite angles of a cyclic quad. And so we could then go work out that angle V is going to be 180 minus 67. I'm not doing the 67 thing. I'm so tired of it now. It's going to be 113 degrees. Okay, so that's going to be 113. Now, this one says, determine the size of S1. So let's just remember that we now have this as 113. Now, S1. Okay, now if we have a cyclic quad over here, we must remember that the angle on the outside is always equal to the inside angle that is on the opposite side. So it's not this one, it's not that one, it's the one that's opposite. So it's equal to that whole angle. So we can say that angle S, no, how are we going to call this? Oh, yeah, we can call it the whole of angle S. So we can say that, well, in the memo, they don't even like really care what you call it. They just want the answer and the reason. But, okay, just know that this little S1, that angle there, plus the 57, should add up to 108. Okay, and that is because of exterior angle cyclic quad. And so if you had to go work out S1, you would get 108 minus 57, which is 51 degrees. This question here, calculate the size of angle WQR. So WQR, okay, so that's WQR. Sounds like tan chord, because here we've got a tangent, here we've got a chord. And so if we can now just take that chord, so you put your finger over there, and you put your finger over there, and you just follow your finger, where does it come together? There and there. So at that 57, we can then say that that 57 is exactly the same as this angle here. And that's just going to be because of the tan chord theorem. In the diagram below, A, B, E are points in the circumference of the circle. AB is produced, EC is a tangent, and then, okay, so everything that they've mentioned here is already on the diagram. First question, prove that for 5 marks. Yo, uncle, can't we get a warm-up? Prove that BCDE is a cyclic quad. So BCDE, so BCDE is a cyclic quad. Now some learners are like, sir, it can't be a cyclic quad because there isn't a circle. But guys, cyclic quads don't have to have circles for them to be called a cyclic quad. All that it means is that, okay, so if you do have a circle, if there is a circle and it touches the circle in 4 different places, then it's automatically a cyclic quad. But if the circle is not there, then there are certain properties that we can prove that will tell us that it is a cyclic quad, such that if we had to then put a circle there, it would touch in 4 different places, okay? But certain quadrilaterals are just not going to be cyclic quads. For example, something like that. If you had to draw a circle, okay, well, let's do something like, okay, that's going to be 5 sides. Just give me a moment. So like, let's say you had to try and draw a circle around this thing. It's never going to touch in all 4 places, right? So there are certain properties that we can prove that will tell us that if we had to go and draw a circle, it would touch in 4 places. So for example, there probably could be a circle that you could draw that would touch that circle in all 4 places. So the circle doesn't have to be there to call it a cyclic quad. Okay? So, but if the circle is already there, well, then we can say it's a cyclic quad because it touches in 4 places. So how do we show that something is a cyclic quad? If there's no circle, well, there's 3 different ways that we need to go look for. So, what are the different properties of a cyclic quad that we know? Well, we know that the opposite angles should add up to 180. So, opposite angles are supplementary. That's the mathematical way of saying it, which means that they must add up to 180. The other thing we know about cyclic quadrilaterals is that the outside angle, so for example there, will always be equal to the opposite inside angle. So those two would always be equal. So exterior angle equal to interior opposite angle. And then lastly, it's like this whole bow tie thing. So if you get a cyclic quad, so let's say they give you a shape like this, and then you've got like a bow tie vibe going on. Can you see the bow tie? If I had to take the cyclic quad away now, you would see the bow tie. See it? So if you've got a bow tie vibe going on, and if you can show that these angles are the same, okay, or these angles are the same, then it must be a cyclic quad, because that property that I'm showing you, where those two are the same or those two are the same, that only happens when you are inside a circle and you've got that whole angle in the same segment vibe. That can only happen in a circle. So if we find that happening in this shape, well, then it must be a cyclic quad, because it means that a circle probably is able to fit around, and that's why those properties are being able to be true. Okay, so we can say, let's just say bow tie, or angle in same segment. So if we can show any one of those 3 things, then we can say that this thing is a cyclic quad. Okay, so let's go fill in the basics of what we do know already. So they've told us that this line is this, or this length is the same as that length. So within that triangle then, that means that that triangle is isosceles. So, you know, that means that those 2 angles are the same. So I'm just going to say let's write it down here. I'm going to say let angle E4 equal x. Okay, so that's x. Then angle D will also be x. Therefore, D would also be x. And that's because of those being the angles that are opposite equal sides. So now we've got that, and that is x. Okay, the next thing we know is that we have a tangent. So that always gives us some good info. So if we have a tangent and we have a chord inside the circle, then the angle that is between them will always be equal to the inside angle that is made by those 2 chords. So you see how we take this chord over here, and we take our finger and we make them come together over there at A, then it means from the tan chord theorem that this angle and this angle is the same. So we can't say it's x because we don't know if they're the same, but let's let E3 equal y. Okay, then we can say therefore angle A is also going to be y, and that's because of tan chord theorem. So the next thing I immediately see now is that we've got a triangle here, and we've got the exterior angle of that triangle. It's y and x. Can you see it's the y plus x? So we know that when you have a triangle and you have an exterior angle, let's just make this a little bit better. Like let's say, for example, this is 30 and this is 70, then this one is automatically 100, because the exterior angle is always the sum of the 2 opposite interior angles. So this x plus y must be the sum of this one and this one. So if you then just look at the maths behind all of that, we could say that these 2 added together must be the sum of these 2. But because this is already a y, then what does that tell us about B1? It means that B1 would have to be x. So we can just say B1 is going to be x because of exterior angle triangle. Why am I doing that? Exterior angle of a triangle. Okay? Now here's where the magic should reveal itself to you. So if we have an x over here now. So now if you look in this shape here, which is the one that we're trying to prove is a cyclic quad. Can you now see that we have pretty much shown that this exterior angle is the same as the opposite interior angle? And so because of that, it must be a cyclic quad. So we can then say, therefore, angle B1 is the same as angle D. And then we can say, therefore, BCDE is cyclic quad. And that's just because of converse exterior angle cyclic quad. So now for the rest of the question, just remember that that is actually a cyclic quad, because then it allows you to use all other cyclic quad properties. So let's actually just remind ourselves, this is now a cyclic quad. So as I said, you can now use all the other properties. Like you can now use angles in the same segment. So for example, you could say that that and that is the same, or you could say that one and that one is the same. Or yeah, there's a bunch of stuff you can say now because it is a cyclic quad. And so we've done this question. Now this one says, prove that these two triangles are similar. Now these are such easy questions normally because they're telling us the triangles, they're telling us the order and everything. So it's triangle CEB. Okay, so triangle CEB is this one over here. Okay, and then triangle CAE. So that's this larger one. So why are they equal to each other? Well, can you see that they both share this angle C2? They both have that angle. So we can say that that's the first one. So we can say C2 is equal to C2, and that's just because that is common to both. Now, we can already see that we've got the y and the y over there. So we can just go and say it again. So we can say that E3 is the same as angle A, and that was because of tan chord theorem. And then we pretty much done, because remember guys, when we are proving that two triangles are similar, if we can find two angle pairs, which we've done over here, then the third angles are always going to be equal because of the sum of angles in a triangle. Just an example, if that doesn't make sense to you, if you have two triangles and we've just shown that, or let's say this one is looks a little bit different. So let's say we've just found that this is 70 and this is 70 and this is 30 and this is 30 over here. Then, and we've just shown that these two are the same obviously and these two are the same. Well then the third angle pairs, which is this one and this one, they have to be equal, because if you just use sum of angles in a triangle, this would have to be 80 and so would that. And so that is what we are saying, that once you have found two angle pairs, then the third one is always the same because of some angles in a triangle. So what angles haven't we used yet in those triangles? Well, in the yellow one, we haven't used that angle. Okay, so that is angle CBE. CBE. So that must be the same as, now what haven't we used in the purple one? Well, in the purple one, we've used C2, we've used A, but we haven't used this angle, which is AEC. AEC. And that'll just be because of sum of angles in a triangle. And so there we've gone and proven it, and so we can then just say, therefore, triangle CEB must be similar to triangle CAE, and the reason is angle, angle, angle. Done. This next question is for 2 marks. It says that. Now normally, well every time, what I would do is I'll take our previous answer and I'd go make the ratios. CE over CA equals to EB over AE, and that's equal to CB, and that's over CE. And the reason for that, you can say corresponding sides in proportion, or you can just say it's because those are similar triangles. And then I would simply go and look for everything that we can, or as much as we can find here. So CD, okay, there's no CD here, but don't worry, it's probably going to be because CD and CE are the same, but we'll look at that just now. EB, where's EB? There it is. AC, there it is. AE, There it is. So it means that we must choose these two as our next part of the question. So we go CE over CA equals to EB over AE. But now the missing one is, what they want is CD, but we have CE. But we know from our diagram that CE is the same as CD, so we can just remind the examiner that we know that. So CE is the same as CD, and that was given to us in the beginning. And so then we can replace that with CD, EB over AE. And then you just get CD alone. And so you're going to end up with EB times AC over AE. Done. Okay, so this one says, prove that for 3 marks, CD is a tangent to the circle ABD. So circle ABD. ABD, okay. So ABD is a circle, so then it's going to be something like that. Now CD, they want us to prove that that is a tangent. Okay, so here's the tangent here. So let me just draw my circle a little bit better. Oh my goodness. Okay, so we want the circle to kind of just hug that. So there, like that. So if that is a tangent, so let me just draw that tangent a little bit better. Let me just do this whole thing a bit better. Now we have a tangent. Oh yeah. Now if you have a tangent and you have a chord, then the angle that is trapped in between the tangent and the chord, which is this one over here, which is D2, that must be the same as if you take that chord. So here, if you put your finger on either side of that chord and you let your fingers come together somewhere on the edge of the circle, that would be over there. So what the question is actually saying is show that this angle is the same as this angle over here. That is what we now need to try and show. That this is the same as this. But it definitely is, because we know that this is a cyclic quad, and so we know that you can use the bow tie. Now if you just make the bow tie, then can you see that this angle D2 must be the same as this angle E3. You know, when you have a bow tie, guys, inside a circle or inside a cyclic quad, these angles are the same, angles in the same segment, or these two are the same, angles in the same segment. So if you look carefully, we've got that over there and over there. And remember that this is a cyclic quad, so we can use these properties. So we can go say that angle D2 is the same as angle E3, and that is because of angles in same segment. And so then we also know that E3 is the same as angle A. We've already proven that, so we can just say that E3 is the same as angle A, and that's already been proven. And so can you see what we've now done? We've just shown that this is the same as that, and that is the same as that. So what it then means, therefore, is that this is the same as that. So we can then say, therefore, D2 is the same as angle A, and that's what we wanted to prove, so that we could say that that circle, or that line is a tangent to this circle that goes like this. Because if you have, once again, if you have a tangent and you have a chord, and you have the angle in between that chord and the tangent, then that angle must be the same as the angle that that chord makes inside the circle. And so that is when I said, okay, put your finger on the edges of that chord and then take your fingers together, boom, boom, and it made this angle over here. Okay, so we can then say, therefore, CD is a tangent, and that's just because of converse tan chord theorem. Okay, so for this next question then, I'm going to also fill in that we now know that that is y, that little piece there is y. And then this whole angle was x. So that whole angle is x, that little piece is y. And we now know that this is a tangent, only if we had that circle there though. I just don't know what we need for this next part. Okay, now this question for 6 marks, geez, like EB squared over AE squared equals to that. Okay, so I wouldn't look at the diagram at first. I would always look at all of the previous stuff that we've got. So we've had that in the past for this question, and we've looked at this over here. So I would go and remake those fractions again. So CE over CA equals to EB over AE, which is equal to CB over CE. Okay, and then we also have this over here. Now, you can spend some time while, like, you can pause this video and you can play around. And, I tried a few things before, and I was going around and trying a few things. And then the one thing that worked was when I did the following. I decided to take this one and this one and have a look what happens here. If you take CE over CA equals to CB over CE, if you cross multiply, you end up with CE squared equals to CB multiplied, well, I'm going to write it as BC instead, BC multiplied by AC, okay? Then what I did is I said, okay, I remember from earlier that CE and CD are the same. So then I went CD squared. Well, let me just write it here. I said CD squared. Then I know that CD can be rewritten as this. So I went and did that. And then that's all squared. And the reason I did that is that I know that if I now square the EB, I get EB squared. And if I square the AE, I'm also going to get AE squared. Okay, so if we go and distribute that 2 into the expression, okay, so we'll get EB squared, AC squared, and AE squared. Okay, and then on the right, BC times AC. Now we want EB squared and AE squared, so we need to take this over to the right-hand side, so we'll end up dividing. So we end up getting BC times AC over AC squared. Now, you see how we have 1 AC at the top and 2 at the bottom. So if we cancel them, that'll cancel and you'll just be left with that. And that's literally what they wanted. So I can't give you specific techniques on how to do this. I had to play around with it quite a bit. You try random stuff. Trust me, when I look at it, my mind isn't just like I'm just gonna somehow know exactly how to do it. No, I had to manipulate, try 1 or 2 things. Some of the things didn't work, and then eventually you try something, and it just kind of gets to the final answer. In the diagram below, PQRS is a rectangle. I'm just looking for things that are not mentioned on the diagram. XY is perpendicular to PS, got it. QY to YR is 4 to 3. QY to YR. Okay, so I'm going to make this a 4x, and I'm going to make this a 3x. And then it says PQ is 28, got it? And PR is 42. PR, where are you, PR? Oh, okay, so they haven't shown that on the diagram. So sometimes they don't show everything on the diagram. Most times they do. So that length is 42. So let's rather go PR. Oh no, I don't want that color. It's a bit too much. Let's just do that and that. Lekker man. So let's do this one. First question, 2 marks. Prove that XY is parallel to PQ. XY and PQ. Okay, so XY and PQ. Okay. So because it's a rectangle, we know that the corners of a rectangle are always 90 degrees. So can you see that now we're going to get some type of co-interior over here, right? So let's go, so we can first go say that angle P is going to be 90 degrees. And we can just say something like angles of a rectangle equal 90 degrees. And so now we can see that that's 90. And so we can see then that these two angles are going to add up to 180. And so we can literally now just go and say, okay, so that means that XY must be parallel to PQ. We can just say the cointerior angles, are supplementary. What that means is that the cointerior angles, which is this one and this one, they are supplementary, meaning that they add up to 180. And so because of that, we can say that those two lines are parallel. Okay, so moving on to 10.2 now, it says determine with reasons the length of WR. So that's this one over here. Now, remember that we now know that these lines are parallel, and we also have the entire length of this line, it's 42. So if you had a random triangle like this with parallel lines, and you knew that this entire length was 18, and you knew that this was 2x and this was 3x, and you had to work out, for example, let's say RT, then you could say, for example, RT over the complete length is equal to 2x over the complete length. And that would just be proportionality theorem, which we're now learning in grade 12. Whenever you have a triangle with parallel lines, you can then say, that over that is equal to that over that, or whatever. And so we're going to use that exact same type of method now, where we can just go and say, okay, so WR over the entire length, which is PR, we can make that equal to RY over its entire length, so I chose RY because RY goes with WR, and then the entire length would be RQ. Now you can say here prop theorem, and then you would have to say which lines are parallel, or you can just say line parallel one side of triangle. That's the other reason we're allowed to use. Now if we go fill this in, we're going to say WR over PR, which is 42, and then RY is 3x, RQ would be 3x plus 4x, which is 7x. These x's would cancel, and so WR is just going to end up being, you can just multiply this 42 up there, so that's going to be 3 multiplied by 42 divided by 7, and this should give us 18. So we can just say 18 units. 18 units. Okay, and then lastly, this question over here says, determine the length of XW. Okay, so they want this length over here. Well, what we can do is just go work out or show that this big triangle and this little triangle, we can show that they are similar. And then once they're similar, we can go make our ratios, and then we would be able to solve this length as an unknown. And then we know that this entire length must be 28. And so then we can just subtract. Okay, so for now, we're just going to go prove. So in triangle, let's do the small one first. So R, W, Y, and triangle, what's the big one? RPQ, PQ. Okay, so we're going to go prove that those two triangles are similar. So we know that they're both going to share this angle R2. So we can say that angle R2 is going to be the same as angle R2, and that is going to be common. Now, these lines are parallel. So you could use corresponding, and you could say, for example, that you could say this angle here, which is W2, is the same as P1. You could also have used the corresponding with those two. You could have said that this one and this one, it's completely up to you. So I'm going to go with this direction over here. And so I'm going to say that W2 is the same as P1. And that's just going to be because of corresponding angles. And that's because the line PQ is parallel to WY. And then remember, guys, when you are solving two triangles that are similar, if you have already found two angle pairs, then the third will always be the same because of sum of angles in a triangle. Or you could have used corresponding again if you wanted to. I'm just going to use sum of angles in a triangle, so that'll be y1. So angle y1 is going to be the same as angle q. And that's just going to be because of sum angles of a triangle. And so therefore, we can now say that triangle RWY must be similar to triangle RPQ. That's the correct order. Then what we can go do is go make our ratios. So RW over RP must be the same as WY over PQ, which must then be the same as RY over RQ. Now the reason for this, you can say line corresponding sides in proportion, or you can just say similar triangles. Now we're trying to find WY, so we want to get WY. Oh no, let's go fill in what we have. Sorry, that's what I wanted to do. So we can fill in, do we have RW's length? Yes, RW is 18, so we can fill that in. RP is the 42. WY is the unknown. And then PQ is 28. Okay, we don't need to go any further. We can actually just stop right there. And so if we now go and solve for WY, you would eventually find out that WY is going to be 18 times 28, and then divide that answer by 42. WY would be 12. Now, can you see though that if WY is 12, so this length here is 12, and we know that the entire rectangle width is 28, well then you can just say 28 minus 12, and that'll be 16 units.